So, let me start with a little story. So imagine that you're an operations engineer. You're working from some company doing large-scale media monitoring. That company, perhaps. You're part of a team that deploys and runs, hundreds of services onto hundreds of physical machines in several data centers all around the globe. Yeah, you got the mental picture? All right. So to compound the problem, all the dev teams, and there's a dozen of them, they're on a 6-week release train cycle. So every 6 weeks, there's a hardening sprint where you fix all the bugs. There's a code freeze. And then there's acceptance testing. And then comes the dreaded day when it's time to deploy. There's a go, no-go meeting, and if they say go there, you know that the next day, you're gonna have to tag and roll out hundreds of services all at the same time. All right? So what do you think usually happens, the day after these deploy days?
You don't go home for 2 days.
Yeah, everything on fire all at the same time. And that's, what happens when you push 6 weeks of coding for a dozen other dev teams, hundreds of services, all into production at the same time, in that same little maintenance window. Everything on fire at the same time, of course. So, about a year ago, we were here in this sort of situation. Today, we are, better. In some parts, we're even awesome actually. The teams here in Gothenburg, they develop microservice-based code. They tag individual components, which produces automatically a release, a Docker image. They update a config repo with a new version number or the new config, and then they just push that to Git. Deployment happens automatically. So for the developer, all he has to do to push his new version of a single microservice into production is tag that release in GitHub, change the config repo with a new version number, a new config, whatever, push that config change, magic happens, out into production. No downtime, no interruption to service at all. We want to be here for all our services. Currently, we're there for a handful of services. So we're working towards that. So I'll be showing you a bit of a smorgasbord on technologies that will help you make a similar journey as we're on. We're not using all of the technologies I'm talking about today. We're using some of them, and I would be most happy to talk about the ones we're using and the other ones out there in the industry today. Mainly the ones involved in container orchestration, rolling upgrades, service discovery, that kind of technology. All the things that help you take your Docker-based architecture to the next level. So, I'd like to start with a quote from the Continuous Delivery book. If you haven't read it, please do. It's trying to express that basically the problem of getting your source code into production. It's not as simple as it might sound sometimes. Especially when you have lots and lots of services, all of them tightly interwoven in dependencies on other services. There's lots of traffic, of course, all the time, around the clock, because you're a global company. Thousands of requests per second. Yeah, you want to be able to deploy many times a day. Microservices should be deployed whenever they're ready in small increments, so you lessen the incidence of fires, or at least the fires are small and easily solvable. You deploy something and then something breaks, well, you can be fairly certain that, hey, I did that change to the system and this broke, so there's some correlation there. If you deploy everything at the same time, it's hard to say what caused what. All right, since you're also processing documents, processing messages all the time, you're serving requests all the time, you can't really have a maintenance window. Take the system down for 4 hours and manually upgrade everything, in a nice, cozy manner. It's not feasible because the business wants the data, they want the apps to be online all the time, and the users expect it because if you bring down the app during their office hours in China, well, that doesn't work. So there's no natural maintenance window if you're a global company. So what happens if you have autonomous teams that can basically decide, hey, we want to use this tech stack because that's where we want to be. That's perfect for our use case. Well, you end up with using all the stacks probably, or at least a large part of them. I think the only stack we're not using is like C# or .NET. Cascading failures, that's something to talk about later perhaps. What happens if you have slowdowns in one part of the system that causes pileups, long queues in request queues or message queues, just backpropagating through the system. If you have a complex system with spaghetti dependencies and services, you get into these sort of complex systems effects, where one part subtly changes or circumstances change, and that causes chaotic changes in other parts of the system. Deployments, that can be quite disruptive, causing chaotic effects. So you want things to be stable. So this is our situation here. And we have gradually created and are transitioning to an architecture that helps us tackle these problems. So, in the background here you see a little bit of our systems actually, about half perhaps. And only the services. Each of them are replicated many times. So it's a complex problem. In the story I described the manual release process basically. You have operations engineering doing deployments manually, going to SSHing into machines and running commands there. Then SSHing into that machine, run some commands there. Different tech stacks. Some services are Node.js, some are Java, some are Python. All of them are deployed differently with different deployment procedures. Yeah, that is a recipe for human error, which we see, of course. So, a few of the solutions that help you combat these things are, first of all, try to solve the, the combinatorial explosion of deployment procedures and tech stacks. So, use Docker or something like it to containerize, meaning you package all the different tech stacks into a standard shippable runtime format, Docker being the prime case. As was described by Joachim, for example. This helps you create the deployment procedures and orchestration systems that can understand the common container format. It doesn't have to care what's inside the stack or what's running there. You can just care about that. Another thing is, you want something, you want more than Docker. You want something to help you orchestrate the whole thing. So you don't have to SSH into machines. You can just do a git push or push some button or something, and things will just happen. You don't want to care about machines, though. That pet machine has Ruby on Rails, that version. That machine has Java version 7. That machine has Erlang VM version something. You don't want to care about all that. It's very complex when you have lots of different tech stacks. And another problem, if you don't care about machines anymore, how can one service find another service? Because with an orchestration system, they typically can run anywhere in the cluster. So you need something like a service discovery system that helps services find other services. And service A here doesn't care if service B is redeployed while it's using it. It shouldn't need to care, at least. It should just continue working. So you want a service discovery solution that will help you deploy pieces of your service spaghetti without causing other services that depend on those services to be interrupted, right? So any service can be deployed at any time without interruption to other consuming services. Lots of different ways to do that. I'll be happy to talk about any of them. To solve these kind of problems, well, you need a PaaS, a platform as a service. It helps you orchestrate, it helps you do containers at scale, it helps you do service discovery. And there's loads of them. This whole space of technology is just exploding. We're using this one. Unfortunately, I have a team of infrastructure developers to help me. But seriously, we're basing it off Mesosphere. So we aren't rolling our own. Completely at least. Yeah. So a few takeaways here is, as previous speakers, get some sort of containerization in place so you can encapsulate the tech stack and isolate it from how you deploy and release things. Evaluate the different PaaSes available because they're not one size fits all. Some work in cloud, some work on premises, some work on both. They all have differences in complexity and differences in what they will do for you. So study these things before you make a choice. And try and aim for having service discovery be independent from your apps. Because if you have 100 services, do you really want to embed some library into all of them so that they can discover where another service is running at the moment? Nah. You probably want something that will, that the service itself doesn't need to care about. That something could be, for example, proxies or load balancers. I'll be happy to talk about that as well. So, in summary, there's a lot of things happening in this space. If you're new to it, suggest topics and I'll be happy to help you navigate it a bit and share experiences from our journey. All right, thank you.
Thank you.